All right, hi everybody. Welcome back to the section 4.1 video. And in this video, we're going to be talking about the superposition principle and how the superposition principle helps us define a general solution to a differential equation. So the superposition principle is a theorem. And what this is that the sum, or the mathematical term superposition, of two or more solutions to a homogeneous linear differential equation is also a solution. Okay, so summing up the possible solutions to a homogeneous differential equation. So here's the superposition principle. So say we have solutions, y1, y2, all the way up to whatever order this differential equation is, k, could be kth order. We have that many solutions to a homogeneous, nth order differential equation. So the linear combination of these solutions is y equals some constant c1 times y1 plus c2 y2 all the way up to however this differential equation is ordered, cky. Okay. And the C's are just constants. But what this is saying is that if we add up all the solutions to a differential equation, their linear combination is also a solution. Okay, so let's look at an example that we've seen before. So if you can recall a bit in example 2 in this section, we saw that a solution y1 equals c1 e to the x, and another solution y2 equals c2 e to the negative x are both solutions to the differential equation, the homogeneous differential equation, y double prime minus y equals 0. Therefore, by the superposition principle, their linear combination is also a solution. Okay, so their linear combination, what would that look like? Well, their linear combination would be y equal just adding them together, c1 e to the x plus c2 e to the negative x. So their linear combination is also a solution, is a solution to y double prime minus y equals 0. Okay, so that is what the superposition principle gives us. If we know they are individually solutions, their combination, meaning their sum, is also a solution to the differential equation. So let's go ahead and try out this with an example. So let's verify a superposition. So we're given the second order differential equation. It's homogeneous. It's y double prime plus y prime minus 2y equals 0. It's a second order. And we're given the solutions. Y1 equals c1 e to the x. Y2 equals c2 e to the negative 2x. And we want to verify that their linear combination is a solution. So we want to verify their sum is a solution. So this is a second order. So what I need to do with this linear combination that we're trying to verify that as a solution is I need to take a first and second derivative, plug back into the equation, and then verify that it's a solution. So let's get the first derivative. This would c1 e to the x would stay the same. And then the derivative of my second term, gotta be careful with the chain rule. This would be 2c2 e to the negative 2x. And we take a second derivative. Once again, C1 e to the x stays the same. And then second term, we need to be careful with the chain rule again. This would end up being 4 C2 e to the negative 2x. So we take all of our components, y prime, y double prime, and plug in to the differential equation. So let's do that down here below. Y double prime, that's C1 e to the x plus 4 C2 e to the negative 2x. That's my y double prime plus y prime. That would be C1 e to the x minus 2 C2 e to the negative 2x minus 2. I'm going to plug in y now. C1 e to the x plus C2 e to the negative 2x, and it all equals 0. It's homogeneous, so it all just equals 0 on the right side. So we got a couple things to simplify. We could drop the parentheses now that we inserted in. We want to distribute in this 2 or negative 2 inside. So what I get is C1 e to the x plus 4C2 e to the negative 2x plus C1 e to the x minus 2C2 e to the negative 2x. And now it's minus 2C1 e to the x minus 2C2 e to the negative 2x, all equals 0. Okay, so let's see if anything cancels out. So I have a 4C2 e to the negative 2x. And so we could cancel this 4 out with this negative 2, C2 e to the negative 2x, and then this 2, negative 2. It's like 4 minus 4 e to the negative 2x, and those all cancel out. And likewise, let me use a different color. The C1 e to the x plus C1 e to the x cancels out with negative 2 C1 e to the x. So essentially what I get down here is 0 equals 0, and then it's verified that it's a solution. Or let me write it like this. I'll say solution, check mark. So therefore, the linear combination y equals C1 e to the x plus C2 e to the negative 2x is a solution to the differential equation. Okay, so that's just a bit of what the superposition principle provides for us. We're still building up to a general solution for a homogeneous and eventually a non-homogeneous differential equation, but we're still building up there, and the superposition principle helps us with this building block. So we're gonna continue on building some building blocks and then get to that general solution, but that's it for this video, just for superposition, and I'll see you guys in the next one. Okay, take care.